Welcome to DSA practical video series. Master Professor Ganesh Attarde from ENTC Department SITRC Nashik. Today we are going to see the sixth practical of the subject Data Structure and Algorithm SE ENTC 2015 pattern SPPU. The title of the practical 6 is the implement queue using the array and the linked list. So let's move towards the theory session of this practical. The aim of the practical is implement queue using array and linked list. Write a menu driven program to perform following operation on the queue: insert, delete and the display. Objective of this practical is basic concept of queue, sequential organization of the queue, linked list implementation of queue, the concept priority queue, circular queue and the application of the queue. In a theory part, the array implementation and the linked list implementation of the queue is mentioned. What is queue? The queue is defined as a list in which all the additions are done from one end and removed from the another end. That is, you are adding all the new element is added at the rear end and all the deletion is placed at the front end. So that's why here to traverse the queue we require the two pointer, front pointer and the rear pointer. So let's take the one example here. So very first time, when suppose the queue is empty, then front and rear, these two pointers are initialized with the -1. So rear and front, that is equal to -1. So if front is equal to -1 and the rear is equal to -1, then the queue is empty. So whenever you want to add one item into the queue, then you are first incrementing the rear, and at that incremented rear index you are adding the new element. So addition of the 10, that is queue insert, having the operation, two operation. First is rear is equal to rear plus 1 and the queue of rear is equal to 10, that is your first item. The next one is you want to add the second item in a queue, so that's why you again increment the rear. So rear is equal to rear plus 1 and at that incremented rear you are adding the new item. Again add 3 and add 40. So similarly, suppose if you want to delete an item, then suppose the rear is equal to 2 here, and suppose you want to delete an item, then what happen? You first delete an item, you first
It's
remove
11:30.
the item, and then after that you are decrementing the rear. No, sorry. If you want to delete the item, then what you are doing? Now first here front is equal to -1, and when you want to delete, then the front is incremented and the item is deleted here. So the queue is nothing but the first in first out organization. So let's see the sequential organization of the queue. The sequential organization is very similar to the array organization, but here all the elements are stored in a discontinued manner. Here we require the two pointers, front and the rear. The front is the front at the front you are deleting the item, and at the rear you are adding the new item. So here this is one example here. So let's move toward the programming. So for doing a programming, first you have to open your experiment. So experiment 5a dot, not 5, 6a dot c. So it is the program for implementing the queue using the array. So here first file inclusion is there, and the maximum size of the queue is defined as a 5. Then after that here some function implementations are there, and the queue is declared here. The queue is nothing but the queue of max, that is queue of 5. Then next front and rear is initialized with the -1. Next one, in a main function I am displaying first the menu. Then I am asking to the user that enter your choice. Choice 1 for insert, choice 2 for delete, choice 3 for displaying your item, displaying your queue, and the fourth for exit. Next one is scanf choice. So what the choice has been given to the user. So first, if the case 1 is executed, then the insert will be called. So what insert function doing? In an insert function, what we are doing, if not of overflow, that is if there is no overflow of the queue, then only we are inserting. So enter the item to the insert to insert into the queue. So we are taking that item from the user. Then if front equal to -1, that is queue is empty. So if front is equal to -1, then rear is equal to rear plus 1 and front is equal to front plus 1. Otherwise rear is equal to rear plus 1. In the queue we are adding the item in a queue as a queue of rear is equal to item. Otherwise print the queue is overflow. Same for delete item. If there is underflow, so if your queue is having some items, then only the delete operation will be there. So item is equal to queue of front. So if front is equal to rear, so if front and rear is pointing to the same index, then front is equal to rear minus 1, else front is equal to front plus 1. So printf delete, and we are printing the deleted item. So other queue is the queue is underflow. In a display function, what we are doing in a display function, just we are printing from front to rear. So very simple implementation of the insert item, delete item, and the display function. Let's check the execution of this program. So Control X, Y, and enter. The compilation is GCC -o EXPT6A EXPT6A.c. Okay, successfully compiled, and then after that we will try to run this program. Okay, so very first one, insert item. So choice 1. So suppose 10 is inserted, again insert item, 20 is inserted, 1, then 30 is inserted, 1, 40 inserted, 1, and 50 inserted. And suppose if you want to add one more time, then it is going overflow. Queue is overflow because we are defining the queue size as maximum size as 5. Next one is delete item. So our first item inserted as a 10, so that's why if I am doing a delete item, then 10 should be deleted. So 2, the deleted item from the queue is 10. 2, deleted item 20, 30, 40, 50, and the queue is underflow. So in this way the execution of this program will be done. Okay, let's see the second part of this practical, that is the queue implementation using the linked list. So I'm opening the program as a nano EXPT6B.c. Okay, so this is the queue using the linked list. The same size is defined as a 5. Then queue, the structure is defined. The structure is having the two elements, the data and the front and rear. Next one is type def struct queue. Then the function implementation, init is full, is empty, add queue, del queue, queue rear, queue front, and display. These are the functions that I want to implement. Then the main function, in a main function I am creating the queue. Then after that init queue. Now in init queue function, what we are doing, let's go to the init function. In a init queue function, we are declaring the p of rear and the p of the front is equal to -1. That is, rear and front is taken as a -1. So it is a queue initialization. Then after that, in a do while loop, what we are doing, first we are printing our menu, 1 for add queue, 2 for delete queue, queue front, queue rear, display, and the 5 for display the whole queue, 6 is exit. And enter your choice. The choice has been given in a ch variable. Then switch ch, different cases. Case 1, enter the value to add. So scanf %d address of queue, that is the value to be added is stored in a x. So we are adding in a queue that x using add queue function. So let's move toward the add queue function. So this is add queue function. So add queue function, first check the queue is full or not. So is not of full, not of is full, then only p of rear plus plus for rear is incremented. Then after that p of data of p of rear is equal to value. Otherwise the queue is overflow. And what the queue is full condition is, full condition is p of rear equal to size -1. So it is a rear. So if size equal to size -1, then return 1, otherwise return 0. The next one is the case 2. Case 2 is delete queue function. Delete queue function we are calling, and that is stored in a x variable. So delete, let's move to the delete queue function. In a delete queue function, what first we are checking that queue is empty or not. So if queue is not empty, then only delete from the queue. That is, front is incremented, and at that incremented front we are taking that value. and after that we are returning the value. Otherwise, if queue is empty, then it will print queue underflow. What is queue is empty condition? Is empty condition is if p of front equal to p of rear, then return 1. So is empty condition is p of front equal to p of rear, that is q of front equal to q of rear, then it is empty. Next one is case 3. Case 3 is very simple. Q front, the q front function we are calling. So it is the value at front. Very simple one, very simple implementation of the q front function. Q front function, if q is not empty, then p of value is equal to p of data p of front plus 1. So that is at the incremented front we are taking the data and we are storing the data in a value variable, and q is empty, then it will print q underflow and it will return val. It will return, it is stored in x variable. Here it is x variable, and then we are printing percentage d at different, that is x is at different. Similarly for the rear, so at that rear end we are taking the item and that is stored in x, and we are printing that x here. Then after that, case 5 display, we are displaying the queue, very simple one, from the front to rear. And for 6, the your program get exit. Let's check that the execution of the program. So for first execution, we have to compile the program. So your command is gcc-o expt6b and expt6b.c. okay, successfully compiled, and then after that our binary file name is expt6b. That's why ./expt6b is our command for running our program. So first adding queue, so 10 first I'm adding, then 20, again adding 30, again adding 40, again adding 50, and suppose 5 element, that is the maximum size, and suppose I want to add one more item, suppose 60 I want to add, so it will print the message as queue overflow. The next one is display. I want to display, so this is my queue 10, 20, 30, 40 and 50. The next one is queue front. What is queue front? Queue front is 10. Yeah, 10 is at the front. What is queue rear? Queue rear is 50. So check that it is 50 or not. Yeah, 50 at the rear. Okay. Next one, delete item. Yeah, delete. 10 is remove, again delete. 20 remove, again delete. 30 remove, again delete. 40 remove, again delete. 50 remove, and suppose again I want to delete, then queue is underflow. Okay, so same here, the same execution you have to check, and for exit this program 6, the same execution you have to check, and you will you should get the same output on your from your program. Okay, thank you very